Hello YouTube, my name's Dave. Welcome to my workshop in a single car garage here in South Australia. Come on in and let's see what we can make. Yes, it's me again. Hello. In today's video I'm going to talk about another one of Dave's YouTube follies. About 5 years back I was watching a YouTube by Robin Renzetti showing how he was using a tree taper boring head to machine tapered holes, and I thought, oh, I could do with one of those. So of course I duly had a search here in Australia's eBay, but nothing in Australia at all. So of course I had to then go on the US website, eBay site. Plenty of them there. Anyway, I managed to find one that was a suitable price, and the seller didn't specify that he would or wouldn't post to Australia, so I emailed him, and he quickly replied, said no, it was at USA addresses only. So right, so what I then proceeded to do was to make some inquiries. Now luckily my neighbour next door, immediate neighbour next door, had a relation who lived in Alaska, so I had it sent to Alaska, and then in due course when it arrived they then forwarded it here to Australia, but never used it. So I thought, well, it's about time. It's been sitting in the box, so I thought, well, what I'll do is I'll get it out, show it to you, and hopefully demonstrate it. So here we go. So here we see the magical tree taper boring attachment. Let's see what's inside. Ta-da! Now when it arrived, it never had all these white packing in there. I've made those up to stop it rattling about and things. Now what we have, this is the head, that's the round boring tool, hole already fitted. There's a this one is for squares, few spanners and things. Original Morse taper 4 shank, and it looks as though somebody's made a 1-inch one up, so that's what I'll be using on my Bridgeport clone. I think the easiest thing I can do now is to actually take it out of the box, mount it up in the mill, and show its operation mechanics wise, because I'm handheld at the moment, and I need more than one hand. So will join me over at the machine in a minute. So here I've mounted the head up in my mill spindle. Now I'm hoping to making that out. So I did try it with the door open, but say this being highly reflective, it was causing me problems. So anyway, so as you can see, it's somewhat similar to a standard boring head, except of course that this is D shaped. What happens is the tool holder mounts on this tapered section there, and it's held on by a bolt, and then of course the boring bar goes in the bottom that allows you to to get an initial setup. Now what's different about this boring head is that you can this piece is rotatable anywhere from turn that right now, that's minus, it goes from minus 45 degrees up to 90 degrees. So in fact it will allow you to actually bore a completely tapered hole. But to use it as a standard boring head is normally that it will be at the 90 degree position. I'll just lock that up on there like that. Let's lock that on there, and then of course it then behaves like a standard boring head. Now this top ring is graduated, and it's 5/1000 one complete turn, and that is radius, and there's 10 divisions, so each of these divisions is a 10th radius. So it's quite a fine adjustment. The nice other option that you can do with this is that once you've bored your hole, you can actually, by unscrewing the locking screw here, and with it rotating, if you actually grab this ring, it will actually feed it out and actually face, so that if you was doing a casting, you know, you could bore it in either spot face or completely machine the top face. Now the way that this works is that there's I'll wind it out. There's a special locking screw here on the back. Is the if you partly insert the Allen key, the first bit locks it so that it drives. But if you put the Allen key all the way in, and as I turn it, you can see this slide moves. And what actually happens is, if I wind it all the way out, I don't know whether you're actually making that out in the gloom there. There's a pinion there, which is slowly reduction from the top, and there's a rack on the sliding mechanism. So that's the way that it works. So I think what I'll do is now is I'll set it up and show it working in all three functions. I'll parallel bore a standard hole first, then I'll face the top, and then finally I'll machine a 45 chamfer on it. So just bear with me. I'll be back again soon when I'm ready to start. Catch you in a moment. Right, I've now set the tool up ready for boring. Now what we can actually do with this is to get a rough. I've centered it over the hole. Is to get a rough adjustment. Of course, it is that you can just, by moving this there, we can get it in a rough position, ready for cutting, to save a lot of, because this is very fine. As I said earlier, one complete turn of this is 10 thou in diameter. So you know, you want to get it so that it you know, you don't have to stand there for ages cranking out. So I'll just lock this down. The other thing we need to do in this instance is to tighten. Oh, it's a little bit out of view. Can we move that down? No, we still. Where are we? No, can't see it. Oh, see. That's the trouble with this shiny. It's there. We just tighten that node screw just there, and that'll stop this from moving unnecessary. Right, so I'll just get it set up for. Right, make sure we're running forward. Yeah, we'll put I don't know. Let's try let's try 10 thou cut and see what that does. Right, here we go. Now I'm hoping this camera's not going to shake too much, because it's I've actually got it mounted on the machine table. But now the other thing you have to watch out for this is, of course, you can't run it too fast, because this is quite out of balance. Anyway, we'll give it a little blip, but don't be surprised if the camera shakes and I have to stop and do a rethink. So we'll give this a little try. Yeah, the machine's got a fair bump on it, but no, that wasn't much of a cut, was it? Let's do better than that. Right, so we slacken this off. Give this another, I don't know, a couple of turns, and we'll try that. Now what's happening? Do you know what Davey's doing? I think I'm winding it the wrong. I think I'm winding it the wrong way, because that's got that's taken the cut off. Right. Okay. Let's go the other way then. Right. Sorry about all this. As you say, I mean, at least it's live machining, isn't it? You know, you're actually seeing me right. Why is that not driving out? Have we not got enough tension on that? Didn't have the screw tighten up at the back. Right, right, that should give us a cut now. Right. Too fast really. We'll stop that. We'll stop that. Oh, we're putting him back here. I'm only hand feeding. I could put the auto feed on, but it's a little bit slow really. But this machine, I'd have to open the covers and change the belt for a faster speed. It's a lot of fiddling about. I wish I bought the vari-speed head, but not to be. Right, we'll give that one more go. Now, which way was it? Which way have I got to feed it? I don't know. I forget. So I told you this is the first time that I've used this. So as I say, it's not one of these things that's done a you know, trial run, whatever. You're actually seeing the learning curve of me at the same time. So I'm learning as much as you are at the moment. So a little bit of a chattery finish, as I say, because I'm not feeding very constant, but so you'll get the idea. Right, I'll call that it for that. As I say, it's not a very good finish, but you know, it's just showing the principle. So what I'll do is now is I'll set it up for to face this top surface, and what I'll do is I'm gonna there'll be a slight delay. I'm gonna not that you'll see the delay, but I'm gonna put a bit of spray paint on there, make it black, so you actually see where it's cleaning up. So join me again in a momento. So what I've done now is I've just put a bit of black spray paint on the aluminium, so that you can actually see where the cut is. I've set the tool about 10 thou below the top, and I shall now be holding the knurled ring, which will allow the tool to feed outwards. So here we go. Holding, now grabbing the ring, knurled ring, and should start cutting any moment now. So it's quite slow, as I say, because it's only it's 10 thou in diameter per revolution. So I mean, I won't go all the way out. I mean, we're just showing you as an illustration. A bit of chopper now. Oh, sorry about that. Right. So there we are. That's the standard boring and facing bit, or spot facing, whatever you want to call it. So what I'll do is now is I'll reset this head to 45 degrees, and I'm gonna cut a countersink, large countersink down through. You know, I've got to put it on this edge. That's why I sprayed it black. So you know, when you'll see it in a minute, you'll see where it's starting to do the job. So I'll reset the tool and shall return. Right, we're now set up for the final part. Now you've got to treat this as if it was a countersinking tool. The deeper you go, the bigger diameter you get. So what I've actually done now is I've blocked the quill, so that all movement now is going to be through the tree mechanism. And then if I actually want to make it a bigger diameter, I've either got to lower the quill or raise the knee, and I think probably what I'll do is the easiest would be to raise the knee, I think. So right, let us begin. So I've speeded it up a little bit this time, so I've made the effort and changed the belt speed. So here we go. So what I should be doing is I should be, when it's rotating, I should be holding this big knurled wheel, and you'll see that this will start machining the edge away, hopefully. As I say, this is the first time I've done it, so don't be surprised if whatever the outcome is. Right, so here we go. I'm going to start it up, running faster this time. And that didn't take, don't think that took anything off. No, we haven't quite reached there yet. No, it definitely didn't take anything off. So what we need to do now is to slacken the screw on the back with the Allen key, and then move the tool back up again. So that's the way this works. We'll lock that up again. So what I'm going to do is I'm going to raise the knee up. I don't know. Well, we'll have a guesstimate. I'd say it didn't take anything off there. So I think well let's do a good half mil and see what that does. Again, it's done nothing. I think I'll stop the chat here, and I'll have another think back soon. Right, let's have another go. And it still doesn't look as though it's taken anything off. Oh dear. Never mind, it's all a big learning curve. We just need to slacken it off. Withdraw the tool up again. Lock that up. Right, let's give it a decent crank this time. Definitely got a cut on this time. Right, deep enough. Stop. Undo the locking screw. Oh, that's tight. On the back. Withdraw the tool upwards so she just clears. Lock that up again. Put on another cut, shove another. Right. Alright, I'll do it once more. As you can see, we've actually got it working now. So what we need to do is slacken the lock off. Withdraw the tool upwards, lock it again so that we've got clearance on the top to allow for sufficient another feed. I'll shove another half mil or so on. there we are. Success at last. Well, that was worth a little wait for, I hope. Right, so as we can see, we've got a nice nice 45-degree chamfer on there. Right, so there we are. I hope you can see that. Sorry about the reflection. Oh, and I hope it's in focus. As you can see, there's the ball is still black after we bored it, and then say the shiny bits is the 45 and the spot face. Hope you found that of interest. As per usual, thanks for watching. Please subscribe, click the like button, leave me a comment, drop me an email, whatever. So until the next video, wherever you are in the world, please stay safe, well and happy. Catch you on the next one. Bye.